Sea ice in the Arctic is rapidly disappearing, causing the region to warm nearly 4 times faster than the rest of the planet. Once enough of the ice is gone, scientists worry that 3 major climate systems will pass their tipping points.
If you warm up the region faster, then you start being able to melt more of the Greenland ice sheet, which contributes to sea level rise. You're able to thaw more of the permafrost layers, which leads to more greenhouse gas emissions. But of course, the bigger thing is that you're then changing the temperature difference between the poles and the equator.
And that could push the global scale ocean circulation, known as the AMOC, closer to shutting down. And we know that would have dire consequences. But a group of scientists think they may have found a key to buying more time before these tipping points collapse. When fully scaled, their project plans to use 500,000 underwater drones. But their initial tests were a lot lower tech.
So we get there in January. It was a horrible day, horrible weather. It was like 40, 50 mile per hour winds. We couldn't see anything, and everything was flying away. Everybody is like, this is a crazy project. You need to cover millions of square kilometers and in such an environment.
Andrea is working on a climate change mitigation project that's part nature-based, part techno-geoengineering. But why should we care? Well, the world is warming quickly, and we need to focus on our greenhouse gas emissions to avoid the worst possible outcomes. But we might also have to consider the most promising strategies to buy us more time while we race towards net zero, especially when the stakes are so high. Back in 2012, an astrophysicist started tallying up the climate change impacts he was experiencing firsthand in Phoenix, Arizona, America's hottest city.
People always say, oh, well, Phoenix is always hot. Go back through the records. You see 1913, there were 0 days above 110. In the last 5 years, we've had 3 years that have had well over 50 days above 110. My cactus are dying in my front yard.
But the message he heard over and over at a climate change conference worried him.
There's only one way out. Stop making carbon dioxide.
Ultimately, that is the only way out. And there have been a lot of wild ideas proposed in order to avoid the hard work of getting off fossil fuels. But this particular crazy idea might just be worth listening to.
When it was suggested that, yes, of course, we need to stop making carbon dioxide, but in the meantime, when that doesn't happen, because it hasn't happened yet, what do we do? And with that, I realized, oh, we're screwed, because there's no stopping the fossil fuel industry, at least not in time. So I started to think to myself, if you could do one thing in the climate, what would you do to have the biggest impact?
For most of the last 2.6 million years, we've had a planet crowned with ice, and we still do. But paleoclimate records show that this decrease in Arctic sea ice that we're now witnessing is unlike anything we've seen in the last 1,500 years.
In all likelihood, by 2040, we will see the first blue ocean event. We'll see the Arctic virtually free of sea ice at the end of the summer.
The Arctic is far away from where most of us live, but what happens there affects all of us.
We have been losing the sea ice in the summertime, and so now the ocean's absorbing all of that heat that normally would be reflected back out to space. And you start exposing the darker ocean or the darker land surfaces to the sun's energy, they're going to warm up. So basically what we've been seeing is that the Arctic is warming about 4 times faster than the rest of the planet.
This disproportionate warming of the Arctic region drives thaw of permafrost, the frozen ground that covers much of the region. If warming continues, the thaw could speed up rapidly, releasing trapped methane and CO2, causing even more warming. Some scientists warn of a runaway climate change scenario. Arctic warming is also pushing the Greenland ice sheet to the brink of collapse. If it melted entirely, it alone could cause 7 meters of sea level rise. And last, Arctic warming causes the temperature difference between the poles and the equator to reduce, which, along with the melting of the Greenland ice sheet, plays a role in slowing the Atlantic meridional overturning circulation. Some scientists think that the AMOC has already slowed, and they warn of a total collapse. There would be major sea level rise on the east coast of the US, tropical rain belts would shift, and the ocean's ability to absorb CO2 would plummet, making global warming even worse. So the loss of sea ice is a big deal, and it got Steve thinking.
I am an astrophysicist, but I've also helped with astronomical observations of hyperbelt objects that exist in the cold reaches of the solar system. I model ice volcanoes on Pluto's moon, for example. And so I know a little bit about ice.
So he took that unique knowledge of ice and started by asking a simple question.
Why does the ice freeze? Well, it freezes at the bottom of the ice layer. That's where it's basically the temperature of the ocean. How impossible might it be to raise water from below the ice to on top of the ice so that it could freeze faster? How much ice would you need to make a difference in the climate? How expensive would that be? And we came up with numbers that we published in a paper in 2017 that said, well, it's a big number.
They wanted to figure out how feasible it would be to add 50 centimeters of ice using simple pumps with windmills to power them. If they could add enough ice during the winter months, then it might give the sea ice a fighting chance of lasting through the summer. Steve and his team estimated how much it would cost to realize this dream.
It would take something like $500 billion, and that was promptly lampooned in The Onion.
And while that number was huge, it meant that the project wasn't impossible.
And ever since then, I've been advocating that we should study the artificial thickening of ice in the Arctic.
Just as Steve started to develop a test project, COVID hit and his funding was cut. But then he got an unexpected phone call.
It came as a really pleasant surprise to be contacted by Real Ice. Boy, was that a good day.
This company called Real Ice started testing Steve's hypothesis.
First test was in Nome, Alaska. Very small scale. Our main objective was to see if simple electric equipment could actually perform in an environment like that. Guess what? We went and it worked.
$122, so we gained 26 centimeters of thickness.
But could it be scaled up enough to make a real difference?
You would need, 10 million, 50 million pumps in the middle of the Arctic. It's just too much.
They needed to come up with a way to scale this project without needing humans to do the work. They needed something that could move quickly and avoid the extreme and ever-changing weather of the Arctic.
So our idea is that you do it underwater.
So Andrea and his team got to work developing an underwater drone that could drill through the ice from underneath, pump water, then move to a new site to do it all over again.
They would operate like a mesh, if you want, like a swarm. That one would be able to cover about 2 square kilometers in a winter season. With that in mind, if you wanted to cover 1 million square kilometers, you would need 500,000.
500,000 underwater drones is a lot, but it's nothing compared to the 50 million pumps you would need to do it manually.
We calculated that our yearly intervention, including everything, renewable energy, operations, engineering, we would be in the range of $5 to $10 billion a year to run an ice growing industry. This is a small amount of money. If you consider, then you save trillions, because that's the numbers we're talking about for future adaptation, loss, and damage.
The goal of this project is not to stop climate change. It won't cool the planet in a meaningful way. But if those 500,000 underwater drones can thicken enough sea ice during the winter so that it lasts during the summer, the hope is that it could slow down the warming of the Arctic, and in turn, it could put the brakes on those 3 tipping points that we talked about earlier, hopefully long enough for us to reach net zero carbon emissions. This process almost mimics nature, which created sea ice in the Arctic for much of the Earth's history. But there must be a catch.
Snow on the sea ice actually limits the light that comes in. You don't get like under ice algae blooms or phytoplankton blooms to happen until that snow is almost melted off.
And that algae and phytoplankton form the base of the marine food web in the Arctic.
But if you don't have snow on that sea ice, because now you've put water on it and you've removed all the snow, then that's going to, of course, allow the light to get in earlier when the sun comes back up. And that would alter the phenology of the base of the food web in the marine ecosystem and how that cascades through the fish populations, the seal populations, the bears, everything.
We need to do a proper impact assessment. Let's not forget 4 million people live in the Arctic, over 500,000 of them are indigenous, and they do depend 100% on the sea ice. All climate interventions have some type of impact. Now we need to compare it with a scenario where we're basically seeing an entire ecosystem collapse, because this is what is happening.
So is a nature-inspired technological solution like this the right direction?
I imagine a situation where we manage to bring the sea ice level back to what it was decades ago, when it could reflect so much more light, and this could actually slow down the warming of the region, slow down the glaciers melting from Greenland, trying to slow down the thawing of permafrost and the release of methane in the region, and bring benefits to the rest of the planet.
You know, I personally think this technology is promising, even with all the cons and uncertainties that not only this, but many other geoengineering strategies bring. But it's clear that Arctic sea ice restoration is a long way from being viable on a large scale. One thing's for sure though, we currently have all the tools that we need to reach net zero, like renewable energy, electrification, and other nature-based solutions. And we've already made real progress towards that goal. Perhaps it's wise for us not to think of these geoengineering related strategies as our silver bullet to solve the climate crisis, but instead continue to employ the tools that we already have at our disposal while implementing other more innovative strategies like the one discussed in this episode as they become more practical. But what do you think? Do solutions like this have a place in our toolkit? I'd love to hear your thoughts in the comment section below, and see you next time on Weathered.